So ladies and gentlemen of college algebra, this is it. Last new topic of the semester. Okay, so what we're going to be doing is we're going to be using the formula sheet that you're given for semester 2. And we're going to show you how to find different radians using half-angle identities. Okay, now the good news about this is you can use the formula sheet on the tests. We're giving you the formulas right here on the note sheet. There are three different formulas basically for the three different trig functions that we'll be using. So there's the sine, the cosine, and the tangent. Now all three formulas look somewhat similar, but they have different signs in them, so they work a little bit different, or we're going to just show you how to work them all anyway. Okay, so let's get to the crux of the matter here. So in these types of problems, you're given a radian that's not found on the unit circle. 7 pi over 12 is not a radian you can find on the unit circle. It just isn't there. Now it does exist, but it's not a normal radian. So if you think about your unit circle, 7 pi over 12 is going to probably be about there. Okay, 6 pi over 12 would be right up here at pi over 2. This is the same thing as 6 pi over 12. Okay, so 7 pi over 12 is going to be somewhat up here. But we don't know what its value is. So what we're going to do is we're going to multiply our radian here by 2. If we do that, we get the radian 7 pi over 6. Well, 7 pi over 6 is found on the unit circle. So we can use that information and a formula to find out the points or the values for 7 pi over 12. Okay, so this is how this works. We have 7 pi over 6. We're going to use that in our formula for sine. Okay, so we're going to have 1 minus cosine of 7 pi over 6 divided by 2. It's got a big square root on the top of it. Now, you'll notice in the formula there's a plus or minus. I'm going to highlight that real quick. We're not going to deal with the plus or minus until the end of the problem. Okay, we don't care about it right now. We will care about it eventually. But right now, we're going to deal with the other parts of the problem first and come back to the plus or minus in a little bit. Okay, so what we're going to do next is figure out what is the cosine of 7 pi over 6. Okay, so if we refer back to our unit circle and we look at 7 pi over 6, we're going to find out that the cosine, which is the x term, is negative, oops, forgot to change my thing, is negative root 3 over 2. Okay, so we're going to put the rest of our equation back in place. So this minus sign is not that one that we have written down. I'll get it. It's part of the formula. So we have 1 minus a negative root 3 over 2, all divided by 2. And we have a big square root on the top of it. Don't forget the square root sign. Okay? Now, I'm going to take the two negatives and make it into a positive to save myself some space. Okay? So now what we have is we have a bunch of stuff. Now, the rest of the problem becomes just math stuff. Okay? It's adding and subtracting fractions, multiplying fractions, things like that. Okay, on the top of our problem, we have 1 plus the square root of 3 over 2. Well, we need to combine those. So to do that, we're going to make the denominator of the 1 be 2. So it's 2 over 2, 2 divided by 2 being 1, plus root 3 over 2, all divided by 2, with the big square root sign. Now I can combine those terms. I'm just trying to see how much space I have left, which gives us 2 plus root 3 over 1 big 2, and that's divided by 2 with a big square root sign. Okay, now I have a complex fraction, so I'm going to multiply by the reciprocal of this 2, which is 1/2, to the top. This will cancel out, thinking of that as a denominator of 1. And then we have 2 plus root 3 times 1, which is 2 plus root 3. And then 2 times 2 is 4, with a big square root sign. Okay. Now, we're not supposed to have square roots on the bottom of the fractions, but luckily, we have a perfect square on the bottom of our fraction. So the square root of 4 is 2. Then we have the square root of 2 plus the square root of 3. All right, so this is our answer, but there's one thing missing. Okay. Now we're going to go back to that plus or minus that we had at the beginning. Okay, so we're dealing with sine. So we want to know, in this quadrant, where 7 pi over 12 resides, what is the sine value for that radian? Okay, well, it's in the upper quadrant, so it's going to be plus. And that's it. That is your half-angle formula for sine. All right, next. Next, we're going to look at the cosine. Okay. Again, we're going to use one of the formulas. We're going to use the cosine formula. We have 5 pi over 12. So 5 pi over 12 would be somewhere around here. But we don't know where 5 pi over 12 is as a radian. So we're going to multiply it by 2, which gives us 5 pi over 6. Okay, so now we're going to use the cosine formula for half angles with 5 pi over 6. So we have 1 plus the cosine of 5 pi over 6 divided by 2 with a big square root over the whole thing. Okay, so the cosine of 5 pi over 6 on your unit circle is the x term, which is negative root 3 over 2. So we have 1. This time, since it's going to be negative, it's going to be minus square root of 3 over 2 divided by 2 with a big square root sign. Okay. Now, if you remember what we did in the previous problem, we combined the two terms on the top, which gives us, I'm going to kind of skip a step, it will give us 2 minus square root of 3 over 2. Okay, we had to get a common denominator and then add the numerators together, or combine them at least, with their common denominator. But we are still dividing that whole thing by the 2 on the bottom, which is right here. It still has a big square root sign. Next, just like before, we're going to multiply by the reciprocal of 2, which is 1/2, because this is 2 over 1. These all cross off. We're going to multiply the same thing at the top. Okay, 2 minus square root of 3 times 1, if we're multiplying square root across, is just 2 minus the square root of 3. 2 times 2 is 4, the big square root. Again, you're not allowed to have square roots on the bottom of your fractions. That's not a good math thing to do. So we take the square root of 4, which is 2. So we have 2 minus square root of 3 with a square root sign, all divided by 2. So it's very similar to the last problem we did. Now again, we have to look at the value as if it's plus or minus for this problem. Okay, so we're dealing with a cosine problem. All right. So what is the cosine value in this quadrant? Oops, sorry. Where's the cosine value in this quadrant? Okay, well, cosine in that quadrant, if you look at the quadrants on the unit circle, all the x values there are positive. So this is going to be a plus, and we're done. Okay, so what I'd like you to do is try the next one on your own. So do the same kind of thing we've been doing. Once you kind of get in the hang of what you're doing, the problems kind of become a little bit repetitive, but that's good because repetitive is practice, and then you can be able to do these problems when it comes time for the test. So pause the video for a second. Try number 4. It should be number 3, but try the next problem, and then see what you come up with. Restart the video and see how you did. All right, so hopefully you tried it. You're back for more. So again, we need to find cosine of 11 pi over 12. So if we make our unit circle, 11 pi over 12 would be like here. Okay, if we're multiplying that by, I'm sorry, that's not right. My apologies. I was thinking something else. 11 pi over 12 would be here. Sorry about that. All right. So if we're multiplying this by 2, so we can make it a half angle, it's going to be 11 pi over 6. So that's the value we're going to put into our formula. Remember, our formula is 1 plus cosine of x over 2. So you have 1 plus the cosine of 11 pi over 6 is root 3 over 2, and then divided by 2 with a big square root on it. Okay, and then it becomes just a continuation of what we've already done in the past. So we're going to combine the two terms on the top, so we get 2 plus the square root of 3 over 2, divided by 2 with a big square root. Multiply by the reciprocal of 2, which is 1/2. those all get canceled, and we're left with 2 plus the square root of 3 over 4 with the big square root. The square root of 4 becomes a 2, so we have 2 plus the square root of 3 underneath the square root, and on the bottom of that is 2. One quick thing about these problems, your square root sign should be cut off by this line right here. All right, because if it keeps going down, it still looks like it's over the 2 in the denominator, which we don't want to say that it's happening that way. So we want to kind of have a distinct line of cutting off the square root sign. Okay, hopefully that made some sense. If not, ask a question about it. All right, now we want to figure out what the sign of this is. Is it a positive or a negative? Okay, so we're dealing with cosines. So in this quadrant, what are the cosine values? The cosine values in that quadrant are all minus. So we're going to put a minus sign in front of that. Okay. Okay. This one's a little bit different just because it's a different type of number. It's going to be having an 8 on the bottom of it, but it doesn't really change the problem. It just changes a little bit, but the process is still the same. Okay. So sine of 7 pi over 8. So 7 pi over 8 is going to be about there on the unit circle. Again, it's not on the unit circle, but that's where it would be located, but we don't know its value. Okay, so we're going to multiply this value by 2 to give us 7 pi over 4. Okay, and that's what we're going to use in our formula. We're dealing with sine, so the only difference between the sine and cosine formulas is there's a plus versus a minus. Sine is got the minus. So we're going to have the sine, we're going to have 1 minus 7 pi over 4, and the cosine of 7 pi over 4 is going to be root 2 over 2, divided by 2, with the square root big sign on top of it. Okay, so this still seems, this is still the same process that we're going to be doing. It's just that instead of a root 3, we have a root 2. So we combine the two terms on the top. We get 2 minus root 2 over 2 divided by 2 with a big square root sign on the top. Multiply by the reciprocal. Two minus root 2 times 1 is going to be 2 minus root 2 over 4, the big square root. Again, the square root of 4 is going to be 2, so we have 2 minus root 2, big square root. There's a definite definition between the top and the bottom of our fraction. We have 2 on the bottom there. And now we go back to the sign. Is it going to be a positive or negative? So we're dealing with sine. What is the sine functions going to be? What are the sine values going to be in this quadrant? Well, sine is y, and all the y's on the top half of the quadrant 1 and 2 are all positive. So that's in quadrant 2. So these values are going to be positive. And that's it. Okay. Now we're going to look at some tangent ones. We're going to do 2 examples, and tangent is a little bit more involved. So I've gotten less of them and more space. Okay. So we're going to be going back and forth. So it's the same idea. We're finding the tangent of pi over 12. So pi over 12 would be here on a unit circle. Okay, so we're going to multiply this by 2, which gives us pi over 6. Okay. Now the formula for this, if we go back up to the top, it shows us it's minus on the top and plus on the bottom, but they're both 1 plus or minus cosine. So we have 1 minus the cosine of, I'm going to write it out, pi over 6, and 1 plus the cosine of pi over 6, the big square root. And again, we're going to deal with the plus or minus at the end when we're done. Okay, so cosine of pi over 6 is root 3 over 2. So we have 1 minus root 3 over 2 and 1 plus root 3 over 2. Okay, and a big square root on both of them. Okay, so this works just like the problems we did at the top, but now we're dealing it with both of them. So we combine the two terms on the top and the bottom. So we have 2 minus root 3 over 2 and 2 plus root 3 over 2 with a big square root. Now the difference between this problem and the problems above is that before our denominator was just a 2, and now we have a very complex fraction. So what we're going to do is we're going to multiply by the reciprocal of this, which is 2 over 2 plus root 3. So 2 over 2 plus root 3. All of this will cancel. The 2's will cancel, but the other stuff can't cancel because they have different signs. You can't just cancel stuff out willy-nilly. The whole expression of 2 minus root 3 has to be canceled out with 2 minus root 3, not a 2 plus root 3. So you end up with this, 2 minus root 3 on the top, 2 plus root 3 on the bottom with the big square root sign. Now, this is why we have more space because, well, these are problems are longer. Now what we have is we have a fraction underneath our square root sign, but one of our fractions, the denominator of our fraction has a square root sign in it. But it's an expression, not just a square root sign. So it has a specific thing that you have to do to it, and that thing is called multiplying by the conjugate. The conjugate is the same terms in your denominator, so 2 and root 3, but they have different signs. So this denominator is 2 plus root 3. We're multiplying it by 2 minus root 3. This has nothing to do with what's on the numerator spot. It has everything to do with the denominator. So we're going to multiply by 2 minus root 3 here as well. So let's show you how this works. You have to distribute. Okay, we're going to do that up top. So on the numerators section, we have 2 times 2, which is 4. We have 2 times negative root 3, which is negative 2 root 3. We have negative root 3 times 2, which is, again, negative 2 root 3. We have negative root 3 times negative root 3. Well, negative root 3 times negative root 3 is positive square root of 9, and the square root of 9 is just 3. Okay, that is the numerator. Now the denominator, you multiplied by the conjugate for a specific reason. We'll get into that right now. All right, what the conjugate does is it gets rid of your square root signs. And we're going to show you how that works, because you multiply 2 times 2 in the denominator, you get 4. You get 2 times negative root 3 gives you negative 2 root 3. Positive root 3 times 2 gives you positive 2 root 3. And root 3 times negative root 3 gives you negative root 9, which is just negative 3. So what the conjugate does is it does this. It gives you 2 terms in the middle that both have the square roots, but because they have different signs, they will cancel each other out. Okay, they give you 0. You still have a big square root sign on the top. You haven't gotten rid of that. That's an ugly square root sign. Let me do that again. There we go. All right, now we can do is combine the like terms. We have 4 plus 3 on the top, which gives us 7. We have negative 2 root 3 minus 2 root 3 gives us negative 4 root 3. On the bottom, we get 4 minus 3 is 1. Well, we don't need to write a denominator of 1, so we're just going to write the square root of that. Let's extend that. Okay, so now the inside is done. There's nothing else we can do to simplify the inside. What we have to do, though, is figure out the sign. So we go back to our graph here, or yeah, like our little sketch. We want to know what the tangent of this value would be. So if we think about the tangent is y divided by x. Both y and x terms in the first quadrant are positive. So when you divide them, you're still going to get a positive. So our answer will be positive. The square root is 7 minus 4 root 3. Okay, and that's it. Easy, which is why we're going to do another one. Excuse me. So again, we have tangent of 3 pi over 8. So 3 pi over 8 is going to be someplace about here. Okay, so we're going to multiply this by 2 to get 3 pi over 4, and we're going to use 3 pi over 4 in our problem. So, same idea. Let's just refresh our memory at the top here. For our tangent, it's minus at the top, plus at the bottom. So we have 1 minus cosine of 3 pi over 4, 1 plus cosine of 3 pi over 4, with a big square root over it. All right, if we look at 3 pi over 4 for cosine, it's going to be a negative root 2 over 2. So this will become 1 plus root 2 over 2 and 1 minus root 2 over 2, because the signs will change because the cosine of 3 pi over 4 is a negative root 2 over 2. And it has a big square root sign. As before, we combine the like terms on the top, but we have to combine 2 fractions. So we're going to have 2 plus root 2 over 2, On the bottom, we're going to have 2 minus root 2 over 2. We're just combining fractions. Then we multiply by the reciprocal of the denominator. So we have 2 over 2 minus root 2, 2 over 2 minus root 2. All the bottoms go away. The 2's on the top go away, but because the expressions that are left are not exactly the same, there's nothing else we can do with that except multiply them across, which gives you 2 plus root 2 and 2 minus root 2 with the big square root sign. Now, just like the previous problem we have our denominator having a square root sign, so we're going to multiply by the conjugate. Again, this has nothing to do excuse me, with the numerator. It's everything to do with the denominator. 2 plus root 2, 2 plus root 2. Okay, I'm going to keep going in the bottom here because it looks like I have some more space. So if we multiply it out using distributive property, 2 times 2 is 4 in the numerator. 2 times the square root of 2 is positive 2 root 2. The square root of 2 times 2 is again 2 root 2. And 2 times the square root of 2 is the square root of 4, which is just 2. In the bottom, 2 times 2 is 4. 2 times root 2 is 2 root 2. Negative 2 times root 2, negative root 2 times 2 is negative 2 root 2. And negative root 2 times positive root 2 is negative root 4, which is negative 2. Okay. So, it has a big square root on the top of it. Now let's combine the like terms. I'm going to just go to the side because we're almost done. 4 plus 2 is 6. All right, the other two like terms here are going to be 4 root 2. And the denominator, the two terms in the middle, because of the conjugate, will cancel each other out. 4 minus 2 is 2. All right, now before we had it where the denominator is just a 1, so it doesn't make a difference. But now it's a 2, so now it does make a difference. So we still have a square root on the bottom, or over the whole thing. But wait, there's more, because what happens is you can see here that we have a 6, a 4, and a 2. The square root sign is irrelevant, whatever's in there. We're not using that. We're using the values in front of the square root sign and on the top in the numerator and then the denominator. Notice they are all even numbers and divisible by 2. If we divide them all by 2, we get 3 plus 2 root 2 over 1, which now gets rid of our denominator. Okay. We go back to our sketch of our graph. We want to know what is the tangent function in this quadrant, which is going to be a positive again. And thus concludes half-angle formulas. Please try the practice. These problems you will not get right if you don't practice them when it comes time for the test, which is going to be next week. All right, if you have questions, please ask.